The two equations that I put up early. I put x final equals what? X initial plus v average times t, right? That's one of them. A lot of physics books, when we're talking about the final, they don't put f with it. So you might see that equation written x. When you see x with no subscript, that means the final. So you might see it looking like that. Also, we wrote what? Just a few minutes ago, where's my notes? That acceleration, I can put it there. We said average acceleration, since we're dealing with constant acceleration, it's v final minus v initial divided by t. We said that equation, we can write that as v final equals v0 plus at. Again, if I don't put a subscript with final, just v, that implies final. So if you don't see a subscript for x, that's x final. No subscript for v, that's v final. There's two equations. I'm going to add one more, and that's how do you find the average velocity? If I said to you, these are your test scores. On test 1 you get 50, on test 2 you get 60. What's your average? How do you find it? Add them and divide by 2, right? So it's 1/2 v final plus v initial. So if you want to take, if I number these equations, this is equation 1, EQ1. This is equation 2, EQ2. I'm not going to count this as an equation. So I can take equation 1 now and rewrite that by going x0 plus 1/2 v final minus v initial times t. So I'm taking equation 1, combining that with this, just replacing v final with this, and you end up with that equation, if I need it. So let's take an example and see which one of these equations I'm going to use. Where's my tennis ball? Here we go. Here's my tennis ball. A ball is thrown upward. So here's my tennis ball. I'm going to throw it upward with initial velocity v0. And I'm going to define upward as positive when I give you numbers. Downward is negative. Since I'm throwing the ball upward, has initial velocity of what? 7.3 meters per second. I should have put a plus to indicate it's going upward. But if you don't put a plus sign, it's assumed to be positive. Now, when the ball leaves my hand, there's only one acceleration acting on that, and that is what? Gravity. In which way gravity is pulling? Down. So my acceleration now is negative 9.81 meters per second squared. Negative means, or down means negative, up is positive. So what is the final velocity of the ball? V equals what when t equals in part A, t is going to be 4.5 seconds, and in part B, t is going to equal what? 9 seconds. I get two equations, 1 and 2. I got to decide which one of these has most of the information in it. So let me summarize what I know. I know the initial velocity is what? Plus 7.3. I know the acceleration is what? Negative 9.8. I know the time for part A is what? 4.5 seconds. Now I'm looking for the final velocity. Which one of these two equations has all these parts in it? The second one. So if I'm going to use one of these two equations, it's going to be the second one. Let's now plug in the numbers in it and see if we can solve it. We're looking for v, unknown. Do we know the initial velocity? Yes. Do we know what the acceleration is? Negative 9.8. Do we know what the time is? 4.5. So what's my final velocity? (7.3) minus 9.8 times 4.5. I get negative 36.8. How can that velocity be negative? What does that mean? It's coming down. Right? It's coming down. Oh, wait a minute. It's supposed to be 0.45 seconds in the problem, but that's okay. The ball is coming down. Now, if we fire that from Earth, probably does not go that high. So it's possible the ball never goes that high. We can figure out how high the ball will go. I can get that number. I'm supposed to use like 0.45 seconds. So if I do, how about I'll make this one 0.9 second. Let's see part B now. What's the velocity going to be? It's the initial velocity, 7.3, plus negative 9.8 times 0.9. Still going to be negative, it looks like it. (7.3) minus 9.8 times 0.9. Negative 1.52. So even in less than a second, the ball is already coming down. So if there's a hole in the earth there, I fire from the earth, from the surface, if there's a hole in that, 7.3 seconds later, that ball is still moving down, but at a speed now of 36.8 meters per second. The negative sign indicates it's coming down, not going up. If I ask you, for example, 0.3 second, that number will be a plus. The ball is still rising. 7.3 is not a high speed. Notice, here we go. You can see it. It's going up and it comes down now. So it takes about 1 second to reach that height. Then it's going to start to come down. And it keeps going down, picking up speed. If you neglect the wind resistance, friction, that ball she's keep picking up speed, picking up speed, picking up speed forever. That will never happen. Why? We reach what? Terminal speed in real life. Because you can't neglect the wind and the friction, all that. We reach terminal speed and you will never go past that speed. You know? But if it's in vacuum, you're always going to be picking up speed as you're coming down. You're going to be increasing the rate of how much? 9.8 meters per second every second. That ball is going to be picking up speed faster and faster and faster. Now, if I change that question, I say, you know what, I'm curious, how long would it take that ball, time-wise? How long would it take that ball to go to the mat? You know what, I'll make my new problem. Here we go. A ball is fired. Here we go, tennis ball again. But now we're going to give it some speed. Initial speed is plus 15 meters per second. We fire straight up in the air. The question is, how long? Let's say we're assuming we're on Earth here. How long is the ball in the air? That's question number one. Question number two. How high does it go? Think about this. Here's the ball. You fire it up in the air. Initial speed equals 15. It's going to go up there, up to here. Then it can't go any more high, and then start to come down. Again, I'm neglecting the wind resistance and friction. The reason I'm saying that means the time to go up is going to equal the time to come down. If you neglect the wind resistance, friction. The time to go up and the time to come down is going to be the same time. I only have two equations. Let me write them here. I have V equals V0 plus AT. That's one of them. The other equation, X equals X0 plus average velocity times time. There's my two equations. How long is the ball in the air? I can't really use that one. Why? I don't know what my average velocity is. I don't know what my time is. I'm looking for it. I don't know how high the ball did it go. So well, if it goes up and it comes down, well, these guys are the same. But I still don't know this, and I don't know what that one is. Now give me a 0. I know that's not the case. You throw the ball up in the air, it's going to go up, it's going to come down. Now let's go back here. If the ball stopped going upward, because once you reach a maximum height, it's not going any more beyond that point. Why isn't it going beyond that point? What's going on here? Well, gravity is pulling down. Somebody said gravity. Gravity is pulling down on you. I'll take that one. When you reach up that height, what's your final velocity here? 0. Why? Because if you had any more speed, you'll keep going. If the ball has any more speed, when it reaches the maximum point, that ball will never stop. Will keep going. The fact stopped right here. That means your final velocity is 0. Start to go, then stops. It's going to come down now. Now I know everything. That equation can get me there. So the time to go from here to there, just to the top, let's see, my final velocity is 0. My initial velocity is 15. Acceleration is negative 9.8. And there's t. 9.8 t equals 15. The time just to go up, not up and down, just to go up, it's 15 divided by 9.8. Which is what? 1.53 second. So what is the time will take to go up and down to the same spot? Twice that number, right? 2 times 1.53, which is 3.06, is it?
Yep.
Second. So the time to go up is 1.53. The time to come down is 1.53. Now the second question, how high does it go? Distance I'm looking for. So I got to use that equation. This doesn't help me. This doesn't have any distance in it. I need to know what x is, how high. Here's what I know. I know that the initial position, I'm going to use this as reference to measure the height from it. That's 0. I don't know how high does it go. That's unknown. I'm looking for it. I know the time it took to go from here to there. I just solved for that one. 1.53. I got it from here. Do I know what the average velocity is? What's the average velocity equal to? Isn't that 1/2 V initial plus V final? My initial velocity is 15. My final velocity is 0. So my average velocity is what? 7.5. Can I get now what x is? X sub 0, which is 0. Initial velocity is 7.5. The time is what? 1.53. .475 meters. That's how high the ball will go in the air. Approximately about 35, 36 feet up in the air. So sometimes notice the problem, they leave a lot of stuff out. Maximum height. Maximum height, that means your final velocity is actually 0. Or they might give you a problem like this. A jet came in. Give you a chance to write that. If you ever flown on a plane, let's say a plane is coming to land now, or we can take takeoff here. Here's the plane's going to take off. Initial velocity here, this is starting from here, so that's your x0, which is 0. Initially the plane is sitting on the runway. So what's your initial speed? V0 is equal to what? 0. Then, okay, it's clear for takeoff, so the plane starts to move on the runway, start to pick up speed. And once it hits about 130 miles per hour, so this is roughly 130 miles per hour, the plane rotates, start to take off. If you're sitting by the window and you look in there, you'll see on the runway 8, little tag, 7, 6, 5, 4. What are these numbers on the runway? Anyone? That's how many feet of runway left. So you better not see 0. That's not a good sign. So let's say it took 4,000 feet. I'm trying to mix and match unit now of runway for the plane to take off. So when we took off, you just happen to notice right next to you it says 6, the number 6. And when you saw the plane start to take off, you look, oh, notice there's the number 2. That means there's 2,000 feet left of the runway. So 4,000 feet of runway it took for that plane to take off. That's your distance. What is your acceleration of the plane? You're curious how fast the plane is picking up speed. And while we at it, how long it took the plane, time-wise, 2 questions. How long it took the plane from the minute this started going to take off till the plane's up in the air? Time-wise, how long? We're looking for 2 things. And it doesn't matter which one I'm going to answer first, but let's go through the problem and write what we know. And make sure the units are matching. So here's what we know. We know the initial position is what? 0. I'm measuring everything from that point. So my 6, the marker that's 6,000 feet, that's my initial spot. I'm going to measure from that point. So that's my 0 mark. Again, the plane was sitting on the runway. Actually, you sit on the runway and you wait for the tower. You go, when I go to fly, I go 3437 Mike, ready for takeoff. And I wait. I gotta wait. I can't do anything. I'm on the runway. I can't touch anything till I hear clear for takeoff. Once I hear clear for takeoff, I hit the brake, the gas, and the plane starts to move. So my initial speed there is 0. We know also the final speed the plane reached before it took off. The final velocity is what? 130 miles per hour. I need to convert that to meters per second. Might as well practice with that. Where's my cheat sheet from last class? If you need one, I have some more. Anyone needs one? Miles per hour to meters per second. Can you see miles per hour to meters per second? Here we go. 1 meter per second is what? 2.24. So when the plane takes off, it's moving at a speed of 130 divided by 2.24. 58 roughly meters per second. I also know the distance traveled. It's 4,000 feet. I gotta convert that to meters. Feet to meters. Let's look at that unit conversion again. Now we're looking for length, feet and meter. Notice 1 meter is how many? 3.28 feet. So I'm going to have the distance is equal to 1219.5. How about I'll do 1219.5, round it up, how about 20? Instead of 19.5, I go 1220. Now again, I'm looking for the acceleration, I'm looking for the time. Let me write my 2 equations. Well, not A, V equals let's look at this equation. Can I use that equation? Let's write what we know, check out what we know. Do we know the final velocity? Yes. Do we know what the initial velocity is? Yes. Do we know the acceleration? No. Do we know the time? No. None of us. Not even Einstein can solve one equation that has two unknowns in it. You can't. There's two unknowns here. Two things we know the value for them, A and T. So right now that doesn't help me yet. Let's look at that one. Do I know what X is? Yes. 12, 20, right? Do I know what X of 0? Yes. Do I know what V average? I can find it. So how many unknowns do you have left there? One I should be able to solve for T. So that's the equation I'm going to use first. Now let me find first V average. V average is 1/2 times V final plus V initial, doesn't matter which one you write first. 1/2 of 58 plus 0. Is that 29? So now I'll come back and I should be able to solve for T. I know what X is. 1, 2, 2, 0 equals X sub 0, which is 0, 29 times T. $12.20. I still have the number on my calculator. I can use the whole number actually. Divided by 29. 42 seconds. So it took that plane 42 seconds before it started to take off. Now if I know the time, I can come back to this. Now I know this. Can I find the acceleration? My V is 58. My initial one is 0. My acceleration is unknown. And my time is 42. What is the acceleration? 58 divided by that number, 1.38. .38 meters per second squared. So notice I let the equations take me through. I go, well, this equation will give me this will give me that. You have to look and see what is given to you and which equation that if I plug them in, you only have one unknown. If you have more than one unknown, you can't do it. There's other equations there. And let's look at them and see. I mean, I can try to derive them, show you the math behind them. So there's the two equations. Where are they? I said there are four of them. Well, I'm not counting this as one, actually. With this, that's 5. But there's 1 and 2 so far. So let's look and see if they can come up with other equations, if we can find where the rest of the equations coming from. What's V average equal to? We said what? 1/2 times what? V0 plus V. Remember we wrote V equals, I think, equation 2 equals V0 plus AT. Remember that one? I don't know why I have parentheses there. My brain's thinking ahead. Remember that equation? I think it's a 1 or 2. I think that's number 2 in our notes. So if we do that substitution right here, if we take this and plug it into this one, I can say the V average equals 1/2 V0. Instead of putting V, I can write V0 plus AT. What's V0 and V0? 2V0 plus AT. If you like math, you'll love the derivation. I'll do one. The other one, I just put it up there. Make it easy on you. Now, what do you do mathematically? Didn't you distribute that one? So that's what? What's 1/2 times 2? Just V0 or 1 plus 1/2 AT. That's the V average. Remember equation 1 I wrote today? What was equation 1? X equals what? X sub 0 plus V average times T, right? That was equation 1. That was equation 2 from earlier today. Now, if I do a substitution, take the V average from here and replace it with this, I will have what? X equals X sub 0 plus, let's take the V average, in place of that put V0 plus 1/2 AT, and then you're going to multiply that by T. So this is actually V average, right there, times T. Do the math. And this is equation number 3. And I will not torture you with equation number 4. I'll just put it there. V final squared equals V initial squared plus 2a x minus x sub 0. These are the 4 equations. So here's my nice sheet of paper. I'm going to add these two to that list. Again, as I said before, if there is no subscript, it's assumed to be final. X equals x sub 0 plus V0t plus 1/2 AT squared. And this one, V final squared equals V initial squared plus 2a x minus x sub 0. Again, all the zeros might be i's. Sometimes I use I, other case I use 0 for no reason. It depends which book you grab. So x sub 0, x sub I is the same. V0, Vi is the same. 0 and I are exchangeable. We just interchange them all the time. So an example where that equation might come in handy, otherwise you have to use 2 or 3 equations to get to the answer. Those equations, we use them all the time. We really do. So I know some of you might be, am I going to memorize these? You're going to, all the homework assignment you're going to be doing, you'll be using these, and some goes, oh, I got them. Oh yeah, I got it. You know? There's too many of them. There's a show on TV, I never figured that out, drag racing, they race on the street. And I'm not sure, it's always like there's money, I know they bet money on it, but you see it on TV, they bring their cars and they race there. So we'll do something like this. We have a drag racer. We'll say it starts from rest. And accelerates. At, these cars actually move really fast. We'll go 7.40 meters per second. Here's the question, how far has it traveled and we'll do first part A 1 second, part B we'll do what, 3 seconds. Notice I use 3.00. Why? 7.40. Why? 3 significant digits, yes. So let's write what we know. There's a hidden information there. Look at it closely. What is it? Initial what? Yes. Starts from rest. The word rest tells you what? The initial velocity is 0. So notice it wasn't like flagged, hey, initial velocity is 0. We're supposed to figure that out. We know what? The acceleration, which is what? 7.40. That's per second squared here. We know the time equals what? 1 second. And we're looking for the final velocity. Well, not really. What are we looking for? How far has it traveled? Is that final velocity? No. We're looking for the distance x. Now, when we ask people how far did it travel, if you were to measure that distance, when do you stop? Don't you stop from where the car starts? So you know that's your initial position is the 0. That's your reference. You're going to measure the distance from that. That becomes your 0. Let me bring my 4 equations down. Can I use this equation? No, doesn't have enough information. I don't know this. I'm looking for it. I know this. I don't know this. So 2 unknowns in it. Can't. Can I use this one? And again, let me erase the bar over the A because we're dealing with constant acceleration, so the average is the same. I don't need to put it there. Do I know the final velocity? No. I can find the final velocity, but they're not looking for it. Right? I can find the final velocity, but that's not what the question is. So that doesn't help me.
If you find the final velocity, you can find the average velocity, and you can probably use the first one.
Correct. Or you can go to that one, which is the combination of both. Somebody put them together so you don't have to do that. But you're right. That if you did this and you went back to this one, you end up with the answer. But to avoid doing 2 equations, they gave you that equation. And that's how we came up with that equation, by putting the 2 of them together. So this is just to get you to it in 1 step or 1 equation. But you're 100% correct. If you know the final velocity, you can go and find the average velocity, add them and divide by 2. And once you have the average velocity, you know the time, you know this. So you actually use 3 equations to get to that answer. Nothing wrong with it. I have no problem with that. Or I can use that one because this has all the stuff that I need in it right there. In one step will take me there. X, here we go. X equals x sub 0 plus v0t plus 1/2 at squared. I'm looking for x. Do I know what initial value is? 0. Do I know what the initial velocity? 0. Do I know what the time is? 1. The acceleration, which is what? 7.40. The time is 1.00 squared. How many unknowns you see there? Only one. 1 squared is still 1. So what's 0.5 times 7.4? 3.7 meters. We're looking for distance in meters. 3.70 if I want to use 3 significant digits to match their answer, their numbers. And the last one is at 3 seconds. 3 seconds, what do we have? Same thing. X equals 0 plus initial velocity, which is 0 times the time, which is 3 seconds, plus 1/2 times 7.40 times 3 squared. $33.3. So in 3 seconds, that car was 33.3 meters away. Okay, let's do one more example. And again, I'll do a plane here. We'll see the equation for that. The plane I fly is an Cherokee Archer 3. Holds 4 people. Initial velocity, if I'm standing on the run, I want to take off here. So takeoff right there. I'm looking for the length, like sometimes I have to take off. What is the shortest distance I can take off? I need to know for that plane. Because some place I go to, the runway is really short. I need to make sure before I get there, I can actually take off. So I know at takeoff, I need to have a speed of roughly 68 miles per hour for that plane to take off. Once I hit 68, that nose goes up. Even if you try to hold it down, you're pushing, that thing is going up. So 68 miles per hour, that plane will start to rise. Initially, I'm sitting here. My initial speed is what? At rest? 0. This acceleration, this plane has an acceleration of roughly, the one I fly, 2.20 meters per second squared. By the way, that's the acceleration for a 747, just in case you're wondering. I just used that number. I don't know what the little one has. So the 747 has an acceleration of 2.2 meters per second squared. What is the minimum distance I need for takeoff? The only thing I don't like is this number. That's in miles per hour, right? I had to convert that to meters per second. So divided by 2.24, roughly 30.4 meters per second. So here's my four equations. I'm looking for the distance x. I can't use this directly. Why? I don't know what that. I know the average velocity, right? I don't know the time. So time is unknown and x is unknown. Two unknowns in it. This one doesn't have any x in it. I can find the time, right? Notice I can find the time just like you wanted to do before. If you find the time, you can go back there and plug it in, and you can find x. Or I can find one equation that will get me there. And could it be this one? I can use this one. I don't know x. I don't know t. Maybe that's out. What about that one? Let's try number 4. V squared equals V0 squared plus 2a x minus x sub 0. My V final is what? 30.4 squared. My initial velocity is what? 0 squared plus 2 times the acceleration, which is 2.2, times the change in x, or x minus x sub 0. If x sub 0 is 0, you can just write x there. I can just write x, because my x sub 0 is 0. How many unknowns do you have here? Only one. 4.40x is equal to what? 30.4 squared. That's roughly 922. What is x equal to? 209 meters. (209) times 3.15 roughly. I need about 660 feet of takeoff. So if I find a place that has 100 feet, I can take off. Yeah, as long as it's clear ahead of me. There's a tree right at the end of the runway, I'm in trouble. I'm hitting that tree and I'm dead. You know.